we'll use this dichotomous key to look at the this domain bacteria, and we'll try to explain some interesting species when we encounter it. That is, for those 5,000 species, we have no ability to describe them today, but only mention those that I have some memory of. Also not in detail, because each species in detail can take about a few hours to present. So we can say that the first dichotomous key is that prokaryotes can be divided into domain bacteria and domain archaea. In domain bacteria, we also using the Gram stain to divide into gram-negative ones and gram-positive ones. Gram-negative ones we divide into proteobacteria and non-proteobacteria. So proteobacteria is in that phylum, alpha, beta, gamma, delta, epsilon, and other phyla are gram-negative ones, but they are called non-proteobacterial, non-proteobacterial gram-negative bacteria. For the gram-positive ones, it is further divided to low GC content or high GC content. It's interesting that in gram-positive ones, sometimes their GC content is well below 50%. Some GC content is high, much higher than 50%. Much higher than 50% means that they are 60%, 65%, 70%. And low GC content means that they are 40 or 30%. So this is a great disparity in their GC content. We know that the GC has 3 hydrogen bonds, and the AT has only 2 hydrogen bonds. So this is a big difference in their DNA constituents. So this also reflects their phylogenetic origins. Okay, now let's go into the proteobacteria. This is gram-negative from the chemoheterotrophic. Here, chemoheterotrophic means that its trophy, its nutrients come from different chemicals. Heterotrophic means these species have to take in organic compound for a living. Autotroph means that doesn't need to take any organic compound except carbon dioxide and other basic elements. So chemoautotrophic means that they take in CO2, they take in hydrogen, or take in sunlight, and then they can synthesize all the organic material for themselves. So this is called a chemoautotrophic. And here, and in here, proteobacteria, most of them are the chemoheterotrophic. That means they must take in chemicals, such as the sugars, amino acid, lipids, or those kind of things. So this is the largest taxonomic group. So this is called proteo. Greek god proteus. Proteus is multi-faced or multi-shaped god in the Greek mythology, called Proteus. So proteobacteria means that many-faced, many-shaped organism, many-shaped groups is called proteobacteria. So currently we have 5 classes, and we'll mention only a few species in each class. Okay, now let's see here. This one. And on the left side, it's called this is ones which are called obligate intracellular parasites. So these ones are small bacteria which have to live in the cell as a parasite. So it is called obligate intracellular parasites. So they are small, they infect animal cells, and they cause some diseases, and some of they're called spotted fever. Spotted fever means that this sick animal has a fever, also has spotted dark spot, the red spots all over the body. It's called spotted fevers. And so here I only talk about the rickettsia. Rickettsia is discovered by Ricketts. So it's Latinized called rickettsia. So it is intracellular parasites, but they can culture in the embryo, chicken embryo, and it's very rare. All Coccobacilli, small, very small cells, and it's called arthropod bone. Arthropod means this is an insect. Insect born means it's transmitted by insects, by mosquitoes, or by flies, or other kind of insects. And when they bite humans, they will transfer this rickettsia from one patient to healthy people and produce a spotted fever. So it's a Rocky Mountain spotted fever. And the one which is famous in the Orient called Rickettsia tsutsugamushi. Rickettsia tsutsugamushi. In Chinese, called 恙虫热. 恙虫热. 恙虫 means some kind of sick disease. The disease causing a small insect called 恙虫. In Japanese, called tsutsugamushi. Mushi means 虫. Tsutsu means 恙. Tsutsugamushi. It's called Rickettsia tsutsugamushi. It's a spotted fever in the Orient. Was discovered. This rickettsia was discovered by Japanese, so it's called Rickettsia tsutsugamushi. And this is intracellular parasites. And let me show their presence in the cell. In the cell, and you can see some maybe in the nucleus, some is in the cytoplasm, and this is clearer. In a chicken embryo, when magnify it, we can see this rickettsia as a large slime layer, a thick slime layer. But compared to the cell, chicken cell, we can see it's very small, both in the nucleus and in the cytoplasm. So this is intracellular parasites. Are small and needs transfer by insect from one host to another host. So this is rickettsia. And similar to rickettsia, insect also have its parasitic bacteria. And this is called Wolbachia. Wolbachia is also endosymbiotic parasites. We can see this. It's parasitic to the ovum, egg, the insect egg ovum. We can see that this bright spot is the Wolbachia. This discovery of Wolbachia in insect is very interesting because insect was continuously being infected by this Wolbachia. Wolbachia do not cause the insect to die, but sometimes it can destroy the male or change the male into females. So this is a manipulation of the sex status of the insect as its host. So this has a strong evolutionary force. Which is manipulated by Wolbachia, so that Wolbachia can live comfortably in insect cells. So this is a little similar to rickettsia. in animals. It's called Wolbachia. So if you are interested, you can look into the literature. Another is Brucella. Brucella. Brucella is also parasites, intracellular parasites, and in the animals. And the one important one is called the brucellosis, discovered by a American doctor called David Bruce, so Brucella. And ingesting of unsterilized milk or meat by infected animals, and so it will be getting into human beings and cause a brucella. The brucella, the symptom is sweating and joint pain. It happens in the Western United States. Cases are not many. However, they're often associated with the ranchers or farmers. So this is brucella. So describe this ones. That is, this is parasites or phagocytes. Parasites or phagocytes. And then this one is the parasites of other animal cells. So both in this whole branch, they are parasites, intracellular parasites. And here, when it lives in insects, it's called Wolbachia. Now let's give some introduction to this Nitrobacter. Okay. Here, Prostheca is assistant limb, a helping limb. That is it's called the Prostheca. So in the bacteria, it is extrusion, a hypha or a stork. Bacteria use this one to attach to cell surface, and so this kind of stork bacteria is often found in lakes. So this is the member in this alpha Proteobacteria. And then the natural bacteria. Natural bacteria means that it can oxidize various species of nitrogen to get this energy, such as Nitrobacter, which can oxidize ammonia into nitrous acid, or further oxidize nitrous acid to nitrate. So these are some important bacteria involved in natural environment for the nitrogen cycles. Okay, so here is the table which shows that most of the nitrifying bacteria, that is able to deal with the various species of nitrogen in alpha or beta or gamma, delta class of the Proteobacteria. Only one, Nitrospira, is outside of this Proteobacteria. So this is a spiral. Spiral is a curved form of the bacteria. Okay, so these bacteria are very important in the nitrogen cycles. So these are their shapes. So we can see that nitrous-fying or nitrous-C-fying bacteria can treat all sorts of nitrous compound to more oxidized forms. Okay, now let's go into this Agrobacterium. Agrobacterium. Agro means culture, agricultural bacterium. Here, Agrobacterium. Agrobacterium is able to cause Krangau. Krangau is a tumor of the plant. That is when bacteria invades plant tissue here, and plant tissue was stimulated to grow into a huge amorphous tumor. And this plant tumor is called Krangau. Amorphous mass of hard plant tissue. And it's the reason is that it has a plasmid. Plasmid is an independent chromosome, a small chromosome outside of the bacterial chromosome. So this is called the plasmid. Plasmid means a chromosome in the plasma of the cell, independent from the main chromosome. Okay, plasmid is important in the bacterial genetics. So later on, I'll describe more of the plasmid when we talk about the genetics. So it has a plasmid. It's called the tumor-inducing plasmid. This tumor-inducing plasmid will be transferred from bacteria to plant cells, and this plasmid will stimulate cells to grow. That is, it will tell the bacteria to secrete hormones. These hormones promote the growth, division of plant cells to produce a huge ground cow. And for the microbiologists, they use the plasmid. They modify this plasmid and have this plasmid carry some genes, and this plasmid, when it is transferred from bacteria to plant cells, and it will insert that gene into the plant chromosome. So this is a way to do the plant recombinant gene technology. That is, plant gene recombination is based on this tumor-inducing plasmid. So this is why this become very important. And next to the agrobacterium, we have this nitrogen-fixing bacteria. Here is the Rhizobium or Azospirillum. Rhizobium, rhizo means the root, bium means living things. Rhizobium are the bacteria which can form root nodules, nodule on the root. This is very important because once they form a nodule, then the bacteria will differentiate into a nitrogen-fixing machine for the root cells, for the plant. So if legume plant has this nodule, then they do not need nitrogen fertilizers because they have the fixed nitrogen supplied from this root nodule. But if they do not have this root nodule, then they need to have a lot of nitrogenous fertilizers in order to grow. Yeah, so if those leguminous plants have these root nodules, then they can grow prosperously. That is, they grow very well in the bear fruits. Azospirillum is in soil, so they can live alone. That is, live not as a root nodule, live alone, but they can use plant-provided nutrient to fix nitrogen. That is, they also provide some fixed nitrogen for the plant nearby, so as to have a mutualistic relationship. Mutualistic is that I do some good for you, and you do some good to help me. We help each other. So this is the best way for the interrelationship. Okay. In the related group is called Acetobacter. Acetobacter. Acetobacter is mainly its ability to produce vinegars. That is, if they produce vinegars from the alcohol, this vinegar acidity will change its surroundings so that we can see that it changes color for the environment. So this is very important. This is very important for the production of vinegar. Vinegar is very important human food. That is for the ingredient in cooking. And this vinegar needs to have some air. Its fermentation we use the original material of alcohol. And in the aerobic conditions, it will transform it into acetic acid. And this acetic acid was then harvested by human beings. So we can see that in each nation, we have different kinds of vinegar. In China, we have hundreds of different kinds of vinegars. And also in Italy, in France, they have their own different brands, different flavor of their vinegars. Okay, let's go into the beta proteobacteria. I have to be a little bit faster, otherwise I cannot finish it on time. The beta one, you can see that this is a dichotomous key. I mentioned only a few important ones. The cell bacillus, this bacillus is gram-negative, but it uses sulfur, oxidized sulfur. So this is very interesting. That is, once it's oxidized hydrogen sulfide or sulfur element to sulfuric acid, it produces the sulfuric acid, produces high acid, strong acid. And this acid is sometimes able to dissolve the minerals, the metallic minerals from the ore. So this bacillus was used by mining companies to do the chemical leaching. Leaching means that they just provide this bacillus with some sulfur and some water, and then spray it to the iron ore, the smashed earth-like ores, mineral ores. Then the bacillus will grow by using the sulfur. Now sulfur is turned into sulfuric acid. Sulfuric acid will dissolve copper, or dissolve iron, or dissolve gold particles, small bore particles, silver particles into liquid. And that is, they are solubilized in liquid. And this liquid, the company, the factory can harvest, the turn natural electrolysis, turn into pure metal, that is silver or gold or copper. So this is important in the chemical mining. Okay, now let's get into jump from here to Neisseria. Neisseria is gram-negative coccus. Generally, it is Diplcoccus. It has many fimbriae. And the gram-negative ones. It likes to live in mucous membranes. So one kind is causing the sexually transmitted disease, STD, or venereal disease, VD. Venereal disease is called the Neisseria gonorrhoeae. Neisseria gonorrhoeae causes disease gonorrhea. Gono is seed, rhea flowing out. That is milky sputum or monosputum, milky slimy material flowing out of the sexual organs. This is called the gonorrhea. It's one of the more famous sexual diseases. When I was an officer, military officer in the army, because we are people from ROC has to serve in the army. So I was the logistics officer in the division headquarters, and the artillery officer, who is also a reserve officer, graduate from college. One day he explained to me, wow, he went to the public warehouse, and then felt inflammation in that part. And he asked my advice. I said, get some penicillin, eat it relentlessly until all your bacteria is gone. So he followed my advice, get rid of his gonorrhea. So a little bit of knowledge can help a lot of people. So this is the disease, sexually transmitted disease by this one. It has many fimbriae, so it can attach to the mucous membrane. Another one which is transmitted by droplet is called meningitis. Meningitis is the inflammation of the meninges. Meninges, the covering of the brain, and this is very serious. And this happens in crowded area. That is in the army barracks. Soldiers, they are in the tight groups, so they will spread this meningitis. Also in the nurseries, in the kindergarten, children is likely to get this disease. So these are very serious disease. Patients will get high fever and unable to move, and if not diagnosed, then this patient will die. Okay, so this is a nice area. And let's go to this one, pertussis, Bordetella pertussis. Bordetella is a non-motile rod. The disease it causes is called pertussis. In general English, it's the whooping cough. That is children of the patient coughed so many days. Then this is injured in their throat. So each time you cough, you squeeze your air out. Woo! Like a whooping, so it's called whooping cough. In Chinese, it's called 百日咳, that is coughing for 100 days. It's called, so this is a very terrible disease. And so this bacteria grows in our trachea. Trachea produces toxins and produces constant fever and disease. So this is one of very dangerous disease for children. And the vaccines we give to very small babies, which one contains antibodies, then the vaccine against this disease, pertussis vaccine. Okay, now let's choose this Burkholderia. Burkholderia was formerly in Pseudomonas. Pseudo means false, monas, single-bodied bacteria, motile. Motile means moving. So was originally called Pseudomonas. Now it's called Burkholderia. Burkholderia degrading a lot of organic chemicals. So it's able to contaminate many places in the hospital. So this is a hospital-acquired disease, also called a nosocomial disease. Nosocomial is a disease caused by the hospital. But the hospital is a very dangerous place. If we go there, we'll get many more disease than originally the patient had. Okay, the third, the gamma. For the gamma ones, we only talk about only a few. It's Legionella. Legionella is very important. Okay, Legionella, Legion. Legion is an American army group. It's called a Legion. France has a foreign legion. That is, any renegade who wants to fight is able to fight. Will enlist in the foreign legion, in the French legion. French legion, they speak only French, and they don't ask your past record, whether you're a criminal or killer. They don't care, as long as you fight for the French. Okay, so there's a legion. The reason for the name of Legionella is that many legionnaires gathered in the hotel in Philadelphia, and they got disease, the pneumonia, and after analysis, then found this new kind of bacteria called Legionella. They live in aerosolized water, in the water pumps, that is in liquid environment, and if that liquid environment is aerosolized, that is, the bacteria becomes an aerosol or becomes the droplet, then it can infect the human lungs and cause the legionellosis, that is pneumonia of bacteria. So in 1977, 130 people got this disease. 25 of them died. That is about 20% died. So scientists quickly discovered this species called the Legionella, and called this species called the Legionella pneumophila. Love the lung. Legionella is the genus species. So this is a very famous pneumonia. Now it's not a group disease. Generally happens singly. Only in this case, it happens in a group. Vibrio. Let's talk about Vibrio. Vibrio is a coma-shaped bacteria. This bacteria generally exists in fresh water or in seawater. And two of these causes disease. One is called Vibrio cholerae. This Vibrio cholerae is very famous because it is causing many epidemic in underdeveloped countries, especially when they take water, contaminated water for drinking. And the disease called cholera, because this is lives in the human intestine and then causes severe diarrhea. And this diarrhea, bacteria in the diarrhea goes into the river and contaminates water again, and then will circulate again. So this will cause a huge epidemic, huge death in ancient times. Currently, if a hospital or a place can provide boiled water to patients, then this disease cannot establish itself. This one, parahemolyticus, causes gastroenteritis. So it has a pathogen. It has a toxin. So if we eat raw fish, or this fish meat is contaminated by this bacteria, then we have the foodborne disease, food disease. Happens quite often in Taiwan and in Japan. Okay, now let's talk about this Pseudomonas. Pseudo means force, single-celled. It has a flagellum for motility, and also has ability to use a lot of metabolites. So it is very often contaminant, often present in contaminants. And if patient gets infected in the urinary tract, in the wounds, in the burns, because of getting into the blood, it will cause all sorts of infectious diseases. This is very often nosocomial disease, and also very often occurred in the environment when people works in dirty places. Okay, so Pseudomonas is covered a little bit. Then finally, then let's get into Enterobacteriaceae. Enterobacteriaceae, when we have Aedes here, Aedes, so this is generally a family. And enterics means that it generally lives in the human intestine or animal intestine, and gram-negative ones and generally has lots of flagella or pili for its movement. And very important ones are E. coli, Salmonella, this kind of thing. Okay, and I have to mention that this E. coli is the prototype research bacterium for molecular biologists. E. coli has a genetic system that is as a genetic transfer. 3 mechanisms of genetic transfer. One is transformation, that is if a bacteria releases DNA in pieces, and then bacteria can take up the DNA and change its chromosome. So this is called transformation, which I have mentioned, discovered by Griffith in 1928. Then the bacterial sex is transmitted by plasmid. That is, plasmid is actually intracellular parasites. So it makes a sex pili, and uses sex pili to infect another fresh bacteria. So this mechanism is called conjugation. And the third mechanism is through the bacterial virus. That is, bacteria take in a piece of the chromosomal DNA. Then when it infects another fresh bacteria, it will transfer the bacterial chromosome, a segment of bacterial chromosome, into this fresh bacteria. It's called the transduction. So E. coli has these 3 ways of gene transfer. So this is easy to transfer genes or do gene recombinations using these 3 mechanisms. So these you need to know, as a microbiologist. Okay, Enterobacteriaceae, the major has this 5 genus. And E. coli is the one which is quite often found in human colon. Salmonella is also the same. Introduce some of the hospital diagnosis here. Hospital diagnosis. The principle of hospital diagnosis is to use the minor biochemical differences to do the diagnosis, such as here. We need to see if they have this mixed acid fermentation, such as this E. coli. Mixed acid, it means that it can generate different kind of acid. So see, if we have glucose, then after metabolism by E. coli, can produce lactate and produce acetate, and even some CO2 and hydrogen. So what we can do is that we can have a little tube here. It's called Duran tube. That is, its opening is at the bottom, and the inside is filled with this the same medium. This is to capture the gas it produces. See, it produces the carbon dioxide and the hydrogen, right? So this is uninoculated. It's inoculated. Okay, so once bacteria generated the gas gets into this Duran tube. This Duran tube will have some gas accumulated on the top because it's enclosed, so gas do not escape. So you can see gas here and no gas here. The color is changed from the pink to yellow. This is the color indicator, pH indicator. So it became acidic and also generates gas. So this is a way to do the laboratory diagnosis for different enterics, because enterics has thousands of strands. So we need to verify differentiation between these different species. This is also the same. This is for Enterobacter, called the butanediol fermentation. So glucose after glycolysis by the Enterobacter produce butanediol, also ethanol, also lactate. This is a minor ones. This is minor one. So if this is uninoculated, this is inoculated. So if we inoculate it, and it will change color, also produce gas. So this is the way to differentiate whether it is Enterobacter or not. Okay, so I have explained the principle of laboratory diagnosis for very different species of enteric bacteria. So these are all different genuses of the enteric bacteria. And we use the different tests, the TSI, urease, or Voges-Proskauer indoor test. And these tests are in the small tubes with different color of indicators. And we can see that these are minus, 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 positive, positive, negative. So we can use the reading of negative, positive, negative, positive to identify which kind of species, this bacteria is. So this is the way, the key differentiation method. Okay. We have less than 10 minutes to go. Okay, one very famous enteric pathogenic is the typhoid fever. Typhoid fever is a disease caused by Salmonella. It's a fever and a diarrhea kind of disease, and sometimes can cause death. But some people have no disease, no symptoms, but they become a carrier. And so this one is called Typhoid Mary. This lady works in a restaurant, and many people got sick in New York City. And then scientists traced the origin of this disease to Miss Mary Mallon. But Mary is symptomless, but she infected 53 people. So she was called Typhoid Mary. So this is the way to cause an epidemic for the typhoid. Okay, so these are some tiny bit of history for you. Okay. Pasteurella pestis. This is another pneumonia. It's called Haemophilus. Okay. And I mentioned a little bit of other members of the Proteobacter, the Delta. Delta, you see, Bordetella vibrio. This is a very small vibrio which will parasitize other bacteria, especially in the periplasm. The periplasm, the space between the outer membrane and then the plasma membrane. You can live in there. Bordetella is a leech. Have you heard of leech? The bloodsucker, a long tape-like worm. When it attaches to your skin, will suck your blood to the full. That is, it will drink as much blood as they can, and then drop off. Yeah, in the Western Europe, before the 19th century, doctors have no way to cure diseases, so they take leeches. They grow their leeches and put it on patient's back, and each leech can take about 200 milliliter of blood on the patient. It's called bloodletting. So doctors think that bloodletting is able to cure diseases. But sometimes, most of the time, they kill patients. Okay. Let me introduce some more. Helicobacter is very important, so let me mention it a little bit. Helicobacter, helico meant helix. So this is a bacterium, it's coma-shaped bacterium, that is a little curved form with flagella. As a polar flagella and a curved rod, microaerophilic. This was first discovered by Australian doctors, Marshall, and his colleague. He discovered that this can live in the stomach, that is in the pH 1. So he was curious whether it can cause the peptic ulcer. So he drank a bottle of this bacteria and I felt pain, the stomach pain. So he himself, as a tester, confirmed that it causes the stomach pain. And so later on, he was awarded the Nobel Prize. Originally, people think that peptic ulcer, gastric ulcer was caused by low mood. Low mood, that is, you feel not very good, and your stomach pains, and then so you eat antacid to relieve your gastric ulcer. This antacid makes more than $5 billion per year for the drug companies. But after discovery of this Helicobacter pylori, they suggested that taking antibiotics is able to cure gastric ulcer and gastritis. So this became an infectious disease, bacterial disease. So the whole market of the antacid has disappeared. So they got the Nobel Prize. So this shows that there are many, many new bacterial diseases to be discovered. Okay. Let me summarize the importance of the proteobacteria. That is, proteobacteria are gram-negative ones. They include nitrogen-fixing bacteria, also some chemoautotrophic bacteria, and so many pathogenic bacteria. So this is a very important phylum of bacteria. Okay, I have only 2 or 3 minutes, so let me talk only a little bit about other non-proteobacterial gram-negative bacteria such as spirochetes, cyanobacteria. Okay, let me just talk this and then finish up. Cyanobacteria is one species, one group of bacteria which can do photosynthesis and also generate oxygen. So previously, many bacteria can take up sunlight, but they don't use oxygen. They use inorganic material to take up the electrons. So it's called anoxygenic photosynthesis. And this group of oxygenic photosynthesis, photosynthetic bacteria, is mainly responsible for generating oxygens for the atmosphere. So after their emergence on Earth, then they changed the atmosphere from one without oxygen to one with more than 20% oxygen in the atmosphere. You can see that these are the free-living cyanobacteria. They are like pearls, but some of it, 1 in 10, is called heterocyst. This heterocyst is different from it because it is now do not allow oxygen to come in, but they are able to fix nitrogen for its neighbors. And so these are the circular form of cyanobacteria. These are the filament form of cyanobacteria. So there are thousands of species of cyanobacteria. So they play a very important role in the atmosphere, in the biosphere, for the generation of oxygen. Okay, so I will stop here because I don't want to take up too much of your time. And the remaining material will be taught next week. Next one will be May 12th in the morning. So do you have any question?
Yes, I have a question.
Yes.
How can we remember all of the species that you mentioned in this lecture?
How do you remember?
Yeah.
You don't need to memorize it. You don't need to memorize it. You just read it, get some memories, and then you build the memories by reading more papers, reading more reports, reading more microbiological stories to build up your stack of microbiological knowledge. That is, no one can remember all of these. But if you immerse yourself in the microbiological world, then you will gradually acquire all this knowledge. That is, during the test, it will not be tested. We will not test in this aspect, but you need to familiarize yourself, not by reading about its habitat, its biochemistry, its diseases, all those tidbits of knowledge. Microbiology is full of tidbits of knowledge. But it is not a deductive science. It's not a physics. So we cannot use mathematics to deduce knowledge. We have to read and get knowledge, little by little, piece by piece. So don't worry about those small pieces of knowledge. Just to get a bigger picture of microbiology. Can you understand my? Can you understand?
Well, yes, somehow.
This science is only by you can only obtain it by accumulation. Accumulate, gradually accumulate, and read the stories, read the popular science books, and gradually accumulate knowledge. Many little films on the YouTube, right? On YouTube, on Twitter, on this SNS, right? On this SMS informations, so you can rapidly accumulate much knowledge by reading the films on YouTube.
Yes.
Yeah, knowledge from the YT. This is a legitimate reason to watch your iPhone, your intelligent phone. Yeah, it's easier to get knowledge, both from the Wikipedia, from the Google search, Wikipedia, and YouTube. Then you can knowledges. Okay, any other student? Don't be discouraged. Don't be discouraged. Read it. And also read the PPT first. Also, if there is a recording of my lectures, you can review the recordings. Okay, so then lecture.